Hello everyone, my name is Razia Bagi. I'm presenting on human-caused global climate change. My presentation provides comprehensive evidence on climate change. I'll explain fundamental climate change mechanisms, then I'll examine major biological effects already observed. I'll connect climate impacts to human health. I'll explore available technological solutions across sectors. Finally, I'll assess societal responsibility and action pathways. The greenhouse effect is a natural process where gases like CO2 and methane trap heat by absorbing and redirecting infrared radiation emitted from Earth's surface after absorbing solar energy. This natural mechanism maintains Earth's habitable temperature, but human activities have intensified this effect by increasing greenhouse gas concentrations, particularly CO2, which has risen from 280 to over 410 ppm since the Industrial Revolution. Carbon dioxide naturally circulates between atmosphere, oceans, soil, and organisms through processes like photosynthesis, respiration, and decomposition. According to the 2022 Global Carbon Budget Research, atmospheric CO2 remained stable for 800K years until human intervention. The natural carbon cycle is now severely imbalanced, with humans emitting 10 to 11 gigatons of carbon annually, while natural systems can only absorb 5 to 6 gigatons, resulting in atmospheric accumulation. How does fossil fuel disrupt carbon cycle? Fossil fuels contain carbon that was stored underground for millions of years. When combusted, this carbon is released at approximately 10 to 11 gigatons annually. Natural systems can only absorb about half of these emissions, causing atmospheric carbon accumulation. This disruption also leads to ocean acidification as excess CO2 dissolves in seawater, threatening marine organisms with calcium carbonate structures. Additionally, fossil fuel combustion enhances the greenhouse effect by increasing atmospheric CO2 concentrations. CO2's impact is magnified by its high concentration and long atmospheric lifetime. The resulting temperature increases trigger feedback mechanisms that further accelerate warming, including decreased snow cover, increased atmospheric water vapor, and potential methane release from thawing permafrost. Climate change is pushing species to move north at 6.1 kilometers every decade, and spring is now arriving about 2.3 days earlier each decade. Marine ecosystems are under serious threat, especially coral reefs, which are home to about 25% of all marine life. If the planet warms by 2 degrees Celsius, we could see major biodiversity loss with up to 18% of insects, 16% of plants, and 8% of vertebrates at risk of losing half of their habitat. The IPCC's 2022 report shows how much climate change is reshaping ecosystems around the world. We're seeing things like tree lines shifting the higher up mountains and toward the poles. In the oceans, marine life is under serious pressure, with over 70% of coral reefs experiencing bleaching between 2014 and 2017. Researchers have shown that species are reacting to climate change at different speeds, which is throwing off important ecological relationships. The IPCC warns that we're getting closer to critical tipping points. Tipping points are thresholds where ecosystems could change so quickly and dramatically that we can't reverse the damage. This causes risks like the potential dieback of the Amazon rainforest or widespread coral reef collapse. The 2021 Lancet Counter report shows how climate change is impacting health. Over the past 20 years, heat-related deaths among older adults have risen by about 50%. Diseases like malaria and dengue are spreading as their careers expand into new regions. The IPCC warns that shifting rainfall and extreme weather are threatening food security. Watt's theme also highlights the mental health toll from trauma after disasters to rising climate anxiety. Specifically, The Lancet report stresses that vulnerable communities bear the greatest burden. The IPCC's 2022 mitigation report highlights promising climate solutions. Renewable energy is now affordable and competitive with fossil fuels. Carbon capture can remove CO2 from factories or the air. Additionally, nature-based solutions like reforestation store carbon and protect wildlife. New agricultural technologies reduce livestock emissions, while conservation efforts like assisted migration and wildlife corridors help protect vulnerable species. The IPCC report shows big progress on climate solutions. From 2010 to 2020, solar and wind costs fell by 85% and 55%, making clean energy much more affordable. Electric cars now have lower emissions than traditional ones. Buildings can cut emissions with better efficiency and electrifications, while industries are developing low-carbon cement and hydrogen-based steel. Additionally, digital tech could reduce emissions by up to 15%, and carbon removal tools like reforestation and direct air capture will help us reach net zero. Based on the evidence I presented today, there are reasons for both concern and cautious optimism. The IPCC points to challenges like short-term thinking and the feeling that climate change is distant, but public concern, especially among youth, is rising. Direct experience and framing it as a health issue, as Watts and colleagues do in the Lancet Countdown report, boosts action. While awareness helps, real change needs collective action and strong policies. I believe as impact becomes clearer and technology advances, people will step up. In conclusion, the evidence I shared shows climate change is real, human-caused, and already impacting ecosystems worldwide. Fossil fuel use has disrupted the carbon cycle, strengthening the greenhouse effect and increasing health risks that will worsen without emission cuts. The good news is we have promising solutions from renewable energy to carbon capture, but the challenge is moving fast. While there's cautious optimism, real change will take all of us, individuals, communities, and governments. Here are my references. Thank you so much for listening to my talk.